Hi everyone. Our today's topic is about spectrum of the atom, how it will be, and various electromagnetic spectrums also we are going to discuss in this video. Spectrum defines a group of wavelengths or group of frequencies. What is group of wavelengths and group of frequencies? Let's start with a simple examples, that is VIBGR: violet, indigo, blue, green, yellow, orange, red. This VIBGR contains 7 colors: violet, indigo, blue, green, yellow, orange, red. So total 7 colors. Each color is having its own wavelength or own frequency is common, because all these are under visible light. That's why white light only, part of it white light only. That's why all are having same frequency, even though the wavelength is different. So violet is 0.4 micrometers, its wavelength, and red is 0.7 micrometers. So the remaining colors are varying between 0.4 to 0.7. So this is group of wavelengths only. So it is also called a spectrum. So it is which type of spectrum? Visible spectrum. Means you can get a doubt that there may be invisible spectrum also. Yeah, obviously there is invisible spectrum also. We are going to discuss the invisible spectrum of various types of radiations. The electromagnetic spectrum. So this electromagnetic spectrum contains visible, means it's a small portion of visible spectrum is a small portion of the total electromagnetic spectrum. This is the visible spectrum, and means it is violet and this is red. Before violet, the rays are called ultraviolet radiation, and before ultraviolet radiation, X-rays, and before X-rays, gamma rays, and after red, infrared rays, and after that microwaves, and after that radio waves. The colors, the radiations before violet are having more frequency and less wavelength. And means the frequency will be more at this column, and wavelength is very less. Slowly the wavelength increases, and as we go radio waves, the wavelength increases more. So this is the general form of the wave of various electromagnetic radiation. These gamma rays are useful in cancer treatment, whereas X-rays are useful in the diagnosis, whenever the bones are broken, to take the photographs of the body parts. And ultraviolet rays are mainly useful for the purifying water, and infrared rays are used whenever to send the heat radiation. Example, when you keep your hand near the iron box, suppose this is the iron box, if you bring your palm near it, you may, even though there is no physical contact, you may get hotness due to this infrared rays only. And microwaves, these are used in the telecommunication to send the uh, telephone and internet signals. Radio waves are the best use of the telecommunication purposes, and because they can travel very long distances due to their very high wavelength, nearly 100 kilometer, 10 kilometer to 100 kilometer. It's their wavelength. Means one wave nearly 10 kilometers to 100 kilometer range. So these are the various types of electromagnetic radiation, and these all electromagnetic radiations, the energy of these electromagnetic radiations can be given by Planck's equation E is equal to h nu, where already we explained h means the Planck's constant, and nu is frequency of radiation. All these electromagnetic radiations are having same frequency, whereas the speeds and wavelengths are varying, and all these are electromagnetic radiations are produced due to the oscillation of electric and magnetic fields in the perpendicular directions. Electric field and magnetic fields vibrating in perpendicular directions, these electromagnetic waves are formed. Let's see a sample of electromagnetic wave. This is the sample of electromagnetic wave. So electric field in this y-axis direction and magnetic field is in z-axis direction, and these two are mutually x, y, z, three axis. Nana. This is x-axis and this is y-axis. Z-axis will be outside, but we can't draw the like that. That's why we'll take cross. This is z-axis, but actually it will be like this outside. Same here, z-axis. In the z-axis direction, what is this? Magnetic field. And in the y-axis direction, electric field. This is electric field and this is magnetic field. The resultant wave is, by mixing of these two in the perpendicular direction, the new wave produced is electromagnetic wave, which is in the x-axis. Means when you take the three fingers, forefinger, center finger and thumb mutually perpendicular, your thumb indicates the x-axis, which is electromagnetic wave direction. This is electric field and this is magnetic field. If electric and magnetic fields are vibrating perpendicularly, and for these two in perpendicular direction, the third axis, along the third axis, electromagnetic wave will be produced. Okay, so this is about electromagnetic spectrum. And if you have any doubts regarding this concept, you comment in the comment box. There may be another I will make another video based on your questions and based on your doubts. Okay, thank you for watching my video.